Thanks everybody. So yeah, my name is Val, and I'll be talking about Dagger 2 dependency injection on Android. And it's not just going to be about how you set it up, but how it works. So before I start, I know we have a lot of Android devs here. So do any of you use Dagger or have you used Dagger? So a few. Did anybody actually understand what Dagger does once you set it up? Right, so give you a bit of a background. About 2 or 3 years ago, when I really wanted to kind of like up my Android skill level, I knew there was a few things that were really hot that I had to learn. One was MVP, second one was RxJava, the third one was Dagger. So I kind of wrapped my head around the first two, but every time I kind of came across Dagger and wanted to set it up, I kind of got scared and backed off until I finally decided, okay, I'm gonna get into this and understand how it worked. For a while, I thought I kind of knew how it worked, but then everything changed maybe a couple months ago when Google introduced Dagger 2.11, which brought a whole host of Android components with the idea of making Dagger easier to use on Android. The success is questionable, but I still think it's better than what we had before. So what I'm hoping to do today is to talk about kind of a few things. The first off is talk about what default dependency injection is, meaning in a world without any dependency injection framework, what do we do? The second one is to give everybody a bit of an introduction to Dagger 2, because I appreciate not everybody might have seen it. And then we're going to go into setting up Dagger 2 on Android with a focus of how it works. So kind of demystifying the magic of it. And then we're just going to end with some testing tips with Dagger, because I know kind of that's a topic that some people get into Dagger and kind of worry how it might work. And to preface this, there will be a lot of code in these slides. There's no way of going around it. There is a lot of boilerplate in setting this up. I have tried to make it simple, and I will walk through every single bit of code, but there's some code that will not fit on this TV, just so you know. If at any point you want me to pause and explain, please let me know. Right, so let's start with an easy question. What is dependency injection? Now, in software engineering, dependency injection is a technique whereby one object supplies the dependencies of another object, and that is what Wikipedia will tell you. Now, of course, that is just meaningless until you kind of figure out what it actually means. So let's see a really, really simple example. I will be using Java, by the way, for you Kotlin people. Say we have a user repository that just does like something as like updating a user. Now, to update a user, we need an access to a web API object and a user database object. How do we get those objects? Well, the simplest way to get those objects and the most straightforward one is just pass them in a constructor. You know, that's the age-old thing of any programming language. You have a constructor where you initialize your fields. Now, if we wanted to use this user repository object in a, say, a user controller object, how would we instantiate it? Well, again, in the constructor of user controller, we just can create a new user repository object by passing in the API and the user database that we use. So far, so good. And this might seem very simple, but there are very, very good reasons why we do our object instantiation this way. The first is that it helps us adhere to the single responsibility and the dependency inversion principles, which are kind of solid principles. Basically makes our code easier to test. And because everybody knows, all code is guilty until proven innocent by a test. So in this example, if we wanted to test our user repository, we can just create it using a fake API and a fake database, and then assert things on it as we do in a normal unit test. And I assume everybody tests because you should. Now, this is all fine and good. I mean, I'm just kind of speaking about positives here, but we wouldn't need dependency injection if there wasn't a problem with just using this approach. And the problem would be, say our happy web API and user database objects that we have, say they in turn need some things to get set up as well. Perfectly viable for a web API to need a URL to get set up, and also say a user database to need a database setup object to get set up. Now what we have to do is we have to get back to our user controller object, where we just were instantiating those before, and now add some extra code to get them into a new state. Now, this might not seem like much, like we're not doing that much more. But what happens if we then get another dependency, a second one, or a third one, or a fourth one? Then you're kind of writing a whole bunch of boilerplate code that's not actually helping you. You're just kind of hooking stuff up together, and that's kind of tedious and error prone. Anything that is a repeatable task in programming, in my experience, is error prone. It should be automated. So the promise of dependency injection and why I wanted to learn Dagger or just use any dependency injection framework was that somebody told me that I could take this entire code and replace it with just an inject keyword and everything works. Now, of course, everything doesn't just work that way, but this is our end goal. This is our ideal world. We just prefix user repository with inject, and one will be found for us. It'll be all instantiated, and it'll work magically in our code. Now, how do we do this with Dagger? And this is where I get into the internals of Dagger. So again, at any point, stop me if you want me to clarify something. So when using Dagger, there are two main things you use: a module and a component. Now, a module is a collection of dependencies. This is the objects that you need to inject in your app. So a module provides a collection of dependencies that you then use on inject annotated fields. A component is the glue between these provides methods and the inject annotated fields you have. So basically what the component does is it actually does the wiring. It is what sets your your class members to the provide methods. So basically think of it as the glue. And you see it's an interface because the way Dagger works is it generates code at compile time that actually does everything. Now, the reason it does this is because previously dependency injection frameworks on Android used a lot of reflection, which was slow. Now, the way Dagger 2 works and the way it was kind of sold to everybody and it's the preferred Android way is that it's fast because everything just happens at compile time. And the reason this is an interface is because a Dagger will create the actual user controller component, which will do all the setup for us. So again, rule of thumb: a module provides the dependencies, a component binds them. Now let's look at the module. So we know that this module needs to provide a user repository, but in order to provide a user repository, it needs the things that the user repository needs. So let's start with them. Always start with kind of the simplest object you can provide, the simplest one you can construct. So first, let's provide our user database. So we just have a provide method, and you annotate methods that provide dependencies with this @provides keyword in Dagger. The method name prefix with provide is just kind of it's not necessary, but it's what most people who use Dagger do. So we provide our database, then we provide our web API, and now thanks to the way Dagger works, we can then in our user repository function just pass those as parameters. Because using the provide method has kind of declared these two classes to the dependency graph, which is the list of all the dependencies in your app, and Dagger is smart enough to find them and to find them for you. And when you use them as function parameters, it'll just create them. You never actually explicitly call any of these methods. The Dagger generated code does it for you. So now, if we go back to our user controller object, which was just injecting a user repository, the only thing we need to actually add to get that set is this bit of code here. Dagger user controller component create inject. Now the word Dagger here is a hint to you that this class has been generated by Dagger. And just to remind you, this is the class that is generated. Now this is an interface, and Dagger generates the actual implementation. And the good part about this is you can actually go inside this class and see what Dagger does, and it actually writes code. It writes code pretty close to what we had before. It basically just it basically goes through all the modules, gets the user repository, and then sets it to the parameter, and off you go. All clear so far? Right. Now, things get a bit tricky when you go to Android. Now, this was all nice and simple with Java. Now, things go tricky when you go to Android, and the reason they're tricky is because in Android classes, like say this user activity, which again wants to use a user repository to maybe set the result to something called a user view. Android classes inherently are constructed by the SDK. You cannot construct them yourself. You cannot just call new activity. You can't call new fragment. You can't call new broadcast receiver or whatever. They get constructed for you, so you can't inject things quite simply in them like we had before. So what we want to get to, say we didn't use dependency injection, we would just use the regular constructor injection here. But our end goal, again, with Dagger is to switch to an inject annotated method, again, like we had before. Now, I'm going to show you how our end state is going to look. Now, our end state, once we've set up everything, is just adding this Android injection.inject method into our class, and that'll wire everything up for us. And this is something like, if anybody's using Dagger but hasn't used the latest 2.11 release, this is a new class. This is provided by the Dagger Android modules, which weren't out there before. Now, I'm going to show you how we get to this end state. Now, the first thing we need is a custom application object, and I think everybody who's ever done an Android app has subclassed application. And we add these things to it. Has activity injector, and why we need that is because when you inject something in an activity or a fragment in Dagger, it goes back to the application to get the correct component, or injector in this case, for that application. So therefore, your application needs to be an instance of has activity injector. And then we just create our application component and on create and inject it. Now, you see here application component, and it's something that we haven't seen before. So this is the actual key class that does everything. In Android, most generally, if you're using Dagger, you're going to have an application component that has most of your global dependencies. So think of it as the holder for your singletons, but in this case, it's the thing that will actually do the hard wiring for us. So let's look at that application component. Now, an application component, again, like a normal component, is just a collection of modules, and we know that it can inject stuff into a custom application. Now, the modules that it needs in this case are two. The first is called Android injection module, and the second is called an activity module. Now, an Android injection module is again provided by the Dagger Android library. It's not something we control, and what it actually is it's a collection. It's a map of class names to injectors. Now, again, reiterating this is where the code gets a bit scary, but reiterating the point with which I started, we cannot create Android classes ourselves. They get created for us. So therefore, the application is responsible for injecting things into them. And the way that works is that the application has a map of activity names, or of activity classes, or fragment classes, or broadcast receiver classes, and an instance of an Android injector that for them. And the activity module is what will actually populate this map. Now, don't worry about kind of multi-binds. It basically just makes the map work. Now, let's look at the activity module class. Now, to get the instances, to get the modules that we need to get our activity going, we need a component for it. So let's create that. So we create what is called a subcomponent. Now, a subcomponent is like a regular component, meaning it injects stuff into a class, but it kind of extends the graph of the parent component. So think of it in this way. We have our application component, which provides all of our, that can provide your web API. Using subcomponent, you can say, okay, but I want only this activity to have access to this extra module. So in this case, we add user module to this activity, so only it has access to it. And you can see that user activity component actually extends something called an Android injector. Now, the Android injector is what Android needs to find the component for your activity. They've just named it in a fancy way, but at the end of the day, it's just a component. It just binds all of your members. Now, this wouldn't be Android if this was all we had to do. We also have to add this thing. Now, as I said before, how all of this works is internally, the Dagger Android library has a map of class names to subcomponents. And what we do with these lines of code is we essentially populate that map. We say, Android, there is an activity called user activity, and it uses this Android injector to get all of its bindings. Now, the reason it's actually using an Android injector instead of it's an Android injector factory instead of an Android injector is that Google, when they made this, they didn't want the injector to keep a reference to your activity or fragment because that's bad. So every time you need to inject one, it creates a new instance of it, does all the injection in it, and then it discards it. So that's why this is a factory, and that's why it makes kind of this a bit more complicated. Now, the reason you actually see this kind of builder thing is purely, they've kind of added that purely as a helpful tool. Sometimes when you have modules in your class, you need to provide them an instance of an activity, or like you need to get some kind of they take something in their constructor. The builder is purely provided so that you can set all that up. Not all of your modules are kind of are very, very simple. And now here we come to the beauty of how Google designed this. Because kind of everything, all the Android classes that you can instantiate are in that original Android injection module. If you wanted to replace this with a fragment, all you have to do is take all the activity names and replace them with a fragment, and then that's you. You can just bind a fragment key in a fragment module, and then you can use a user fragment just like that. So it's basically the same code. And this would be the same for broadcast receivers, services, or any of the content providers, any of the other kind of Android classes that you get. Now, good news is that if you have a sufficiently simple string, you don't have to write all of this. They actually recently added a functionality that simplifies all of this to just this. A fancy annotation code that contributes Android injector that you just add to this function, and everything magically works. Now, what this does, it essentially writes the code we had before, but it assumes that your modules don't need any extra setup. So if you, for example, had a module that actually took the activity as a parameter, this won't work. So it only works for simple cases. Right. So we saw a lot of code just now, and probably some of it didn't make sense. So if we can get back to where we started, we'll see if we can kind of trace our steps back and see how everything kind of magically works together. Right. So everybody started, if everybody remembers, we started with this super simple, naive class where we just wanted to inject a user repository, and we thought that if you just add Android injection.inject, it'll work. Now, because of all the setup we've made, it will, but let's see what it actually does. Now, once you code Android injection.inject, it goes into your application, and it says, okay, I need an Android injector for my activity. And this is the reason why this thing here is called a dispatching Android injector. What this does, it doesn't inject all your fields, it finds the correct injector for your fields, just because to make things extra hard. Now, okay, we find this dispatching Android injector. What this dispatching Android injector does is it goes into the application component and says, okay, let me know if you have an Android injection module, and let me know if the entries of it are populated. Now in this case, we have them. So the next step is use the combined modules to find the injector that we need in this case. So what happens here is it goes into an Android injection module. The Android injection module says, I have an entry for a user activity class in my map. Let me go and find it. This thing comes and says, okay, I'll construct you an Android injector factory to inject all your members, which then goes into our user module, because it's the thing that actually provides the user repository for us, and that is what actually gets set. So I'm just going to leave this here for a little bit to let it sink in, because before I actually started doing this talk, I did not know how that vicious circle worked. And I wanted to do my best to kind of explain why it does what it does. And remember, we do all of this because we aim to get everything working at compile time. We cannot use anything like reflection to set this for us. Now, the good part about this is that if you have kind kind of a sufficiently large Android application, you've done this for a few times, you don't need that part and that part. You actually don't, you set those only kind of once. And then the only things you end up needing are your activity module and the actual class that's using it, which kind of looks really similar to our original example, right? Without kind of, if you ignore all the extra bits, what we essentially have here is we have a component for our activity that provides a module which provides our dependencies, which is a much kind of nicer thing to follow and a much nicer thing to understand. Now, the good bit about using this is because this Android injection lookup happens at runtime, you can place it in your base activity. Assume all you have a base activity in your application, and then any other activities just work. So actually, by using this, we've gotten to our promised land of just adding the magical inject keyword and just having everything working. Now, I'm not gonna ask all good because you're probably gonna have to see this a few times to understand it. But a question I've been asked is, what does this mean for testing? Like, we do all this setup. What does it mean for testing? Well, it doesn't make testing easy. But the first thing I'm going to suggest, and the first thing that even Google suggests on their official documentation, is to prefer constructor injection when you can. Now, the way constructor injection works with Dagger is, say you have a user presenter, if anybody uses MVP, a simple class that you control. You can just add the inject keyword to its constructor, and what that'll do is when you inject your presenter somewhere else, Dagger knows how to construct a user repository and it'll assign it to it. And in turn, that gives you the opportunity in a test, because you have a constructor to just provide mocks or whatever test objects you need, to get an instance of a user presenter which is easier to test. Now, in almost all cases, if you can do it, do this, because it's much easier. But if you want to test an activity with ESPRESSO, you are not going to have a bad time, but you're going to have a longer time to actually set it up. Now, to test an activity using ESPRESSO, you need 5 steps. The first one, you need to create a test module for supplying your mock objects. Then you need to create a test component for the application and the activity in question. Then you have to create a test application class, which kind of subclasses your application to wire these things together. Then you have to create a custom Android JUnit runner if you're using an ESPRESSO test that actually instantiates that application. And then you can actually go and create your activity test. Simple, right? Now again, the good part is once you've done this once, you don't have to do steps 3 and 4. You just have to keep 1 and 2 updated and then just create your activity test. Now, in this example, step 1 is we have to create a test activity module. Say we want to test our activity, we just wanted to include our user repository. We need a test user module that provides a mock. In this case, I'm using the Keto, a mock user repository. And then we can just create an Android injector for this activity that uses this new module. Then we have to create our test application component, which can just extend our application component, but unfortunately when we use extension, it doesn't inherit all of the components that we annotated before, so you have to annotate it with all the same components. But the key in this case is that we replace the original activity module with the test activity module. Then create a custom application object for testing, where in this case, I got my original custom application, but the bit that actually initialized Dagger, I moved to a protected method, so I can override here. And in this case, I just instantiate my Dagger test application component instead of my regular application component, which then supplies us with our mock for testing. And after all of this, you can go into your activity test and actually start using it. Now, in this case, I mean, if anybody's used ESPRESSO, this like all of this is stuff you have to do. But then in your test, say if you wanted to get an instance of the user repository you provided for your activity, it'll be a mock because of the way we set up our modules. That was Dagger today, everybody. Nothing to it. And I will take questions as long as they're easy.